By the way, Newton took a long time to publish this law of gravitation. Does anybody know why he was holding back for a long time? Have you heard anything? Yes?
Newton was in the controversy over the discovery of the calculus with Leibniz, and then I think Edmund Halley convinced him later on.
Edmund Halley may have convinced him to publish, but it was something else that was bothering Newton. Yes?
He was afraid of criticism?
He is afraid of criticism. Maybe, but that was not why he held back. Yes?
Did he also doubt it very much?
Pardon me?
Didn't he also doubt that it was possible?
No, but look, when he applied it, by the way, he applied it to everything. Celestial motion, to the behavior of tides, everything seemed to work. There is one further assumption that you make. When I wrote 1 over RE square, I said the distance of the apple from the earth is that. Or maybe it should be just 2 meters from which I release it. Somehow he knew you have to measure the distance from the center of the earth. So it is not clear for the purposes of gravitation. In other words, originally Newton had a law of gravitation between 2 point objects, namely the point like, the distance between them is unambiguously the distance between the points, and he got this law. But in the end, he wants to apply it to the earth and the apple. They are close enough for you. You cannot pretend the earth looks like a point from where I am. It looks like a big fat thing. You cannot say it's point-like. So what you really should do is divide the earth into tiny pieces, each one of which is point-like. Find the force on each, from each chunk of the earth using this law and add it up. And if you're lucky, it will look as if all the pull is coming from one point at the center, carrying the entire mass of the earth. So what branch of mathematics do you have to use to get that result? Yes? What branch of mathematics? What kind of calculus? Had it been invented? No. So he had to then invent integral calculus also. So, if he felt that no one around him was doing any work, probably justified, because they just dumped the whole thing on this kid and said, why don't you do integral? That's why it took him a long time to verify, using integrals, that the sphere behaves like a point particle at the center. He knew it works because all these numbers couldn't be all the coincidences or not coincidence. He believed it worked, but he had not found a way to show it. And that's what held back a publication. Okay, there's another